So the first method theory we'll look at is realism. Realism uh, examines international relations through power. So it examines that causes are related to power. And it tries to explain why war breaks out. It tries to explain national security, the reason to generate alliances, and basically great power politics, how the great powers of any era get along or don't get along, or align or don't align. And so to a realist, the causes of conflict and relations are all related to power. So what they mean by power is a state's material capabilities. So that is basically its population, its resources, its wealth, its size of its military, and what that military can do. And so you will also see it include political stability and competence. Now, these are not necessarily considered to be hard power. Hard power would be those material capabilities that we talked about first: the military population, resources at its disposal, ability to generate wealth, capital. Soft power, so a less tangible, more influx form of power, doesn't include things like political stability. So in short, a state's power may also be aided and founded in part by its stable nature politically. So if you're changing governments every 2 months, you're not what would be considered politically stable. But if you've had the same government for 300 or 400 years, basically, that would be considered a very stable state. And in those stable states, material capabilities can flourish. It's difficult to build a big military, grow the population, grow resources, protect resources, grow wealth, grow capital, grow territorial acquisition when you have unstable governments that change every couple of months. But if you have a stable government that's been around for a few hundred years, and those things are stable, and you also have a government that is competent, meaning that your government tends to make decisions in the best interest of that country, power can be fairly stable. So even if you have a government that's been governing for 400 years, but it constantly makes key mistakes when it could have acquired more wealth, more territory, increased its population, but it didn't, increased its military strength at the borders, but it didn't, etc., these would all be problematic. So realists believe that there is power, and power is very much defined by the relative wealth and resources, capabilities, the size, population, as well as land resource size of a country. And that the primary goal of any state is power. So all states have one primary goal, and that is power, because they believe power and security are equal. Power means security. So if you are more powerful, you are more secure or stable. So therefore, you'll see this word thrown around a lot in your text, and I want to go over this because your text actually misstates a few things about it. First, realists believe or see the world as a zero-sum game for the most part. Now, you may have heard this thrown around a lot. What is a zero-sum game? A zero-sum game simply means that in a game between two competitors, whatever competitor A wins is taken from competitor B. And anything competitor B wins is taken or depriving competitor A. So we play a game of rock, paper, scissors. Okay? And the winner, or we play a game of poker or something. And the winner gets, we bet $10 and we both put up $10. For you to, if you win the game, you get my $10, I lose my $10. If I win the game, I get your $10, you lose your $10. That would be a zero-sum game. So realists, because they see that causes are related to power, right? And they define power in terms of material capabilities. So they see conflict or relationships around the world as strengthening state power, because power means security and the protection of those resources, those material capabilities. And if there was a conflict, it means that one state has taken the other states, some of the other states' material capabilities, or vice versa. So to them, that's why they see this as zero-sum games. Now, be careful. The example used by many as the realist game, the prisoner's dilemma, is a non-zero-sum game. So one of the things I did not like about your text is that the example used as a zero-sum game for realist is not a zero-sum game. So let's take a look at some games before we finish up realism. You will also see a branch of mathematics applied to international relations. You also might see them in your economics classes. It's used in economics as well. Sometimes people are surprised that other social scientists look at this branch of applied mathematics, but this is called game theory. And game theory is simply one tool that people can use in trying to identify optimal strategies in competitive situations. Game theory is not the be-all, end-all of dictating what strategy one must take, but it can be helpful. It rests on certain key assumptions. One, the most important assumption is that you assume that all players are rational. They are rational actors. Okay, this is important because you have to believe that people are rational, because you're going to be basing your strategies on rational plays. Okay, so important to assume that. Now, this is a game that is used in some international relations contexts, and it is a zero-sum game. So what one gets, the other loses. We use a payoff matrix, or a payoff matrix like this, to help us lay out these problems. So what we see here is that this is a zero-sum game, and this is called the Battle of the Bismarck Sea. And it looks at a real situation in the Second World War between the Japanese and the United States. Your book also misplaces player 1 and player 2 in games. Player 1 is always to the left and does the rows. Player 2 is always the columns. And when you list payoffs, okay, you're always listing payoffs for player 1. First, payoffs for player 2 second. In zero-sum games, you do not have to, okay? You do not have to list payoffs in the matrix. So in a simple game setup, if you were to do one, which you don't have to, and I don't want to get too detailed, you can take, there's mathematics courses you can take on it. But the very simple layout of a payoff for a zero-sum game, so I'll move this here. Okay. Excuse me, I just put things in the wrong columns and rows here. So let's just say you have strategy A1. So player A, or player 1, and player A has strategy number 2. And up here, you have player B, or player 2, with strategy B1, his first strategy, or her first strategy, and B2. Okay? Second strategy. In a zero-sum game, since whatever A gets, B loses, and we're telling the story from the perspective of player A in this payoff matrix in a zero-sum game, and from there we can assume what's happening to player B. A1 takes strategy 1 and gets 5. But A1 gets -5. Strategy 2 might be so what's happened here is, you notice I used negative numbers. Okay, so this would be when A1 chooses strategy 1 and B chooses strategy 1, A gets 5, let's say $5, which means B must lose or go negative $5. So -5. If B chooses the second strategy while A sticks with strategy 1, it means A loses $5, which means B must get 5. If A chooses strategy number 2 while B chooses strategy number 1, A loses $3, which means B must get $3. And if they both choose strategy 2, A wins $3, but B must lose $3. So the reason why, if you ever see a matrix in a zero-sum game and you only see one number in the box, okay, it's often because it has to be the opposite. So if you were to add, and one of the other ways you can tell this is a zero-sum game is if you add these two numbers. If you add 5 to -5, what do you get? 5 plus -5 equals 0. -5 plus 5 equals 0. -3 plus 3 equals 0. -3 or 3 plus -3 equals 0. So each sum in each one of these cells equals 0. Now that's a lot of math, and I don't really want to get into much to it, because there's other ways you can examine some games, and this is one. I've chosen an alternative method to make it a little simpler. And that's in the Battle of the Bismarck Sea. So the situation is, the Japanese are trying to pull away from U.S. forces, which have been sent on a mission to bomb and destroy part of the Japanese naval fleet in the Bismarck Sea in the South Pacific. The Japanese have two choices, and these days listed are days of bombing they would face depending on what choice they make. So the Japanese can choose to sail north or sail south. Now notice, the Japanese are going to be bombed. It doesn't matter. It doesn't say that there's a 0, so they will be bombed. The United States has two choices. It can search north or it can search south. So if the Japanese decide, if the U.S. decides to search north and the Japanese sail north into a storm front, they will incur 2 days worth of bombing. If the United States searches north and the Japanese sail south, they will incur 2 days worth of bombing. But if the United States searches south and the Japanese sail north, they will incur 1 day of bombing. But if both sail south, they will encounter 3 days of bombing. So for the U.S., the payoff is they have 2 days in the positive. Hey, we got 2 days of bombing, which means the Japanese have 2 days while they're being bombed. That's a negative outcome. That's a negative outcome. That's a negative outcome. And that's a negative outcome. So if we were to add these cells together, they all equal 0. Now, if you're the Japanese and you're the Americans, let's say you put these tables out here, okay? And you reason to yourself, okay, I know my other commander is rational and is going to do the things that's in his best interest. So if I'm the United States, I know that the Japanese are smart, they're rational, and they're going to choose a strategy which has the least impact on them. So how do we know what is the worst outcome possible for the Japanese? And we look at the worst number for them. -3 is pretty bad. Okay? So that would mean the Japanese in this case would like to eliminate, okay? They would like to eliminate any outcome that gives 3 days of bombing on them. They don't want to be bombed for 3 days. They'd like to limit the damage. So that means they cannot choose to sail south, because sailing south is the only way they can get that horrible outcome. Okay? So if I'm the United States, I know this. And I will assume that the Japanese will therefore choose to sail north. I don't know which way they'll sail necessarily. I haven't intercepted any radio transmissions that tells me which way they'll go. So I have to make a judgment call based on the information that I have. And assuming that they're rational, and assuming that they know that they will lose whatever I gain, so I gain days of bombing, they lose materials being bombed. So that the Japanese, it's logical for the Japanese to sail north, because the worst that can happen is 2 days, which is the best that can happen for them. If they sail south, the best that can happen for them is 2 days of bombing, and the worst that can happen is 3 days of bombing. Whereas if they sail north, the United States at most gets 2 days, and there is the odd possibility that the United States decides to surge south instead, and they only get 1 day of bombing. But as the Japanese, I also understand that the United States probably knows this and will choose to sail north, to search north, because they know that I will avoid sailing south, that I'm going to sail north, and they're going to realize that they're not going to search south and get that maximum 3-day bombing, right? So if I'm the United States, I know the Japanese are rational, and I know they're going to avoid sailing south to get 3 days, so they avoid 3 days of bombing. So I'm not going to search south. I'm going to search north. The Japanese know what I know and make a logical assumption. So, but by choosing this strategy, I at least limit to only 2 days, and if I'm the United States playing rationally, that 1 day is out as well. This is this is actually kind of a complicated zero-sum game. But what you'll see as you play with these, you don't have to have perfect understanding of these yet, is that we need to lay out or have some sort of method of laying out what our options are and what the other side's options are, and assuming we can get into the heads of our opponents or to someone we compete against, and what's logical for them, trying to come up with numerical payoffs and then reasoning it out. And so this is a zero-sum game example. Okay? Now, your book uses the prisoner's dilemma to analyze all of the different perspectives. And the simple layout of a prisoner's dilemma is a non-zero-sum game. Your book calls it a zero-sum game because I guess realists believe that in different iterations of this, you will be losing something that the other side gains. However, from the pure game theory perspective, as we see evidenced by the other theories in international relations, the prisoner's dilemma is a non-zero-sum game. Why? If we look, we have a variety of strategies open to us. And if we look here, the payoffs are both listed. Player A gets the first payoff here. Player B gets the second payoff listed. And that goes throughout every cell. We notice that player A and player B what player A gets is not necessarily something player B loses. You don't see negative numbers here, do you? No. So that would mean the sum of each cell does not equal 0. Therefore, this cannot be a zero-sum game. Now that we're through with the mathematical minutia, let's take a closer look. In the prisoner's dilemma, you have a classic problem where you have two people who've been arrested and accused of a crime. The police split up player A and player B. Let's just call player A Adam and player B Bertha. So Adam and Bertha, modern day Bonnie and Clyde, shall we say. So Adam and Bertha are separated, and they're told by the police, the first of one of you who tells me, who confesses to me, I will make a deal with you. If you confess to a crime and the other one doesn't break, I will treat you as a witness, not as a criminal, as a suspect, and the person who stayed silent or didn't confess will receive 25 years in jail. However, if you confess, you'll receive 0. However, if I have both people confess, you both get 10 years in jail, because you've saved me the cost of a long drawn-out interrogation and trial. However, if they both stay silent, the most the police can put on them is maybe some evidence for illegal gun possession, which results in 1 year in prison. This prisoner's dilemma is one of the most studied games in game theory. Well, it's not one of the most. It's probably the most studied game. So you have a dilemma. If you're Adam, or Bertha, do you choose to cooperate with your other player? So cooperate means you stay silent. Defect means you confess. Now, if you're Adam and Bertha, some things you have to take into consideration. I'm playing this game one time. I have one shot, and that's it. Okay? I only have one chance to make this right. Now, do I trust Bertha? What's in my best interest? So take a minute. I know your book had its own answer, but think about what's in your best interest, what you would do, and then come back. And so pause it, come back, and then we'll go through the rest of it. Okay, now you're back. You thought about what your strategy was. You were going to stay silent or cooperate with the other player, or confess or defect from the other player. To a realist, you play this game one time. And in this situation, your choice should be to defect. Answer is, well, why? The question is why. Why would you choose to defect from your partner? You don't know what your partner is doing. You have incomplete information. And you know your partner, but 25 years in prison is a long time. Do you trust your partner that much? If you don't, or you can't, you only play this one time, so you can't, you're not playing the game multiple times. It's just one time. You have one shot. And so you have to look at this from the standpoint of what is the worst outcome for me? If I'm Adam, player A, what is the worst thing that can happen to me? The worst thing that can happen to me is I go to prison for 25 years. Okay? And the only way I go to prison for 25 years is if I choose to defect or cooperate with the other player. So if I cooperate with the other player, I get 25 years in prison. If I'm player B, the worst outcome for me is 25 years in prison right here. And the worst thing that can happen to player B happens when player B cooperates with the other player. So if I'm player A, the worst thing that can happen to me is I go to prison for 25 years. What's the best thing that can happen to me? The best thing that can happen to me, if I defect and confess, I go to prison for 0 years. Okay, that also means I introduce the possibility of this outcome here, an equilibrium, a 10. Well, but 10 is better than 25, right? Which is not as good as 1 or 0. So if I had to rank what is the best possible outcome for me, 0, right? If I defect, I get 0 years, right? And they cooperate, but I defect, I get 0. But if we both cooperate, I only get 1. Okay. But if I also cooperate, I get 25 years in prison as a possibility. But here, I get 10 years as a possibility. And the same for player B. So what should your choice be? You can only play this one time. Trust is an issue, and you have incomplete information. You eliminate the worst possible outcome for yourself, 25 years in prison, which also means you eliminate the 1 year in prison, which means this is your outcome, depending on what player B chooses to do. Now, player B is going through the same thing. So player B tends to also have the same trust issues and will do the same thing and defect, therefore eliminating my best possible outcome, and this becomes what's called an equilibrium. Now, how is this applied in international relations? So let's take a close look and erase these labels and put in some new labels. So as we're labeling, this is also a way of looking at the Cold War. So that, or the nuclear hostilities between the United States and the Soviet Union after World War II. And while many people advocated for the disarmament of nuclear weapons, which is a noble and righteous goal, if we take a close look here, take a look at the payoffs. So if the United States and the Soviet Union decide to disarm, okay, possibility. But what happens if you go through the payoffs once again? If they both disarm, wow, that's wonderful. You have, this would be the world peace outcome. Or at least, if it's not world peace, it's conventional weapons, which don't do as much damage as nuclear weapons. Okay? So if both sides do go to war, they go to war with conventional weapons. It doesn't kill or destroy as much territory as nuclear weapons would. If the United States disarms and the Soviet Union arms, that means the Soviet Union gains more power, it gains the territory, it can obliterate more territory and everything else. It puts them in an advantage. The United States has no nuclear response capabilities because it disarmed, and it trusted the Soviet Union to disarm, and it didn't, so it defected from that agreement. Now, if the United States goes back on that agreement and secretly arms after agreeing to disarm, but the Soviet Union live up to that pact, that means the Soviets lose, big time in this deal, right? But if both choose to arm nuclear weapons, you have a tense peace. Both sides can do damage, but both sides are at an equilibrium. So they stockpile the weapons, they arm themselves, but they would really like to choose an option where they don't have to fire them. So if we look at this as a prisoner's dilemma, which is one way of examining this part of the Cold War, the question of trust once again becomes important. Can the United States and its allies trust the Soviet Union? You only have one chance in this game, supposedly. Let's say you have one chance. Do you trust them? Do they trust you? The answer is no. So let's say it's 1955. Do they trust each other? Absolutely not. So the United States would like to disarm and have maybe no nuclear weapons, and the Soviet Union would like to disarm and have no nuclear weapons, but they don't trust each other to honor that agreement. So we can cross that option out. We also know that the United States is most concerned about disarming and the Soviet Union not agreeing or following through on their plan, which is terrible for them. So that's the worst possible outcome. So you avoid this totally, so you don't disarm. So that leaves only arming as an option. And the Soviets understand this, and they have the same fears, which means that they don't want to disarm and leave you armed, even though they'd like this conventional weapons peace, which leaves this choice. Both arm. And so that's one way of examining the Cold War, using the prisoner's dilemma. It's been used to model a number of situations, and so in international relations it's also helpful. But it's also important to understand that while your book calls it, or terms it a zero-sum game, it really isn't. Because, as we're going to find, depending on your perspective, you can have different ways of looking at it. Okay? So let's go back and take a look at another game, and that's called Chicken. I don't know if you're familiar with the game of Chicken. Supposedly it was invented by high school teenagers in California back in the 50s, where they'd get on a straightaway, hop in their cars, and run full speed at each other head on to crash into each other. And the chicken was the first player to swerve out of the way. And so that makes you the chicken if you swerve first. Now, in this payoff matrix, if we were to look at Chicken, right? Player A is in his Ford Thunderbird, and player B is in his 57 Chevy. And they're both screaming at each other head on. If both swerve, both decide to swerve, they both become chicken. Okay? This is their payoff. They're both chickens, but they both equally were chickens. Okay? If player A swerves and player B doesn't swerve, player B is the cool, brave guy on campus, the king of the high school, going to be in the hit musical Grease, and player A is a laughingstock. However, if player A doesn't swerve and player B swerves, it's the opposite. Player A is the hero of the school, going to be in Grease. Player B, not so much. He's the chicken. But if player A and player B are so resolute and they choose not to swerve, okay, this outcome is very bad, because that means they've both crashed their car into one another, and being risky young people, most likely aren't the type to have worn seat belts while playing chicken, so both are probably crashing the car at high speed, being ejected from the car, and maybe a fatal injury. But what does this have to do with international relations? Well, if we think about where these payoffs are, what is the worst possible payoff for you in this game? The worst possible payoff for you in this game is actually this one. Because it could kill you. It could cost you your life. So, in this game, if we think about it, if I'm a rational person, I don't want to die. So I cross that one out. I'm player A. I don't want to lose my life. That means, though, that I would have to also eliminate the best possible outcome for me here. Right? 4. King of the school. So if I make a resolution not to swerve, I eliminate my worst possible outcome, but I also prevent my best possible personal outcome. And player B, right? So that means I have to swerve. Player B has the same problem. And so not swerving, okay, is a bad idea. So that eliminates the best and worst possible outcomes for player B. So not swerving doesn't become a really good option if I'm a rational person who wants to live. So we both sort of swerve, and that becomes an equilibrium. How does this apply to international relations? Well, we'll examine this closer in a later unit, and we'll see it again. And that would be a model of the Cuban Missile Crisis, in which the United States discovered that the Soviet Union was deploying nuclear missiles 90 miles off the coast of Florida in Cuba, and it learned it through spy planes. The Soviets were putting it there in retaliation for the fact that NATO and the United States had placed nuclear missiles in Turkey, which was close to the Soviet border. What to do or what to do? In this case, they go through lots of posturing, lots of communicating, lots of talking, and what happens is the United States made a resolution, the Soviets made a resolution, and there became a standoff where the United States blockaded Cuba. So I'll represent the blockade with this circle. Cuba is this line in the circle. And the Soviets sent a fleet to go resupply Cuba. If it violated the blockade, this most likely would have triggered World War III, and a nuclear war at that one. The Soviets turned back, and the United States and the Soviets made an agreement. The Soviets would withdraw the missiles from Cuba, the United States and NATO would withdraw the missiles from Turkey, and ultimately what happened is both sides swerved, realizing that these options, the benefit was not worth the great risk. So both sides eventually swerve. So this is also another way of looking at international relations. Realists will use this method at examining international relations. And here, to finish up realism, so we talked about the belief in power and everything else. We see the use of games and how they're useful for realists. They also believe that there's no single legitimate source of power in the system of the international system. So states must help themselves instead of relying on other states. So in other words, each state is an actor on its own, and that there really is no real international order, so to speak. And so what you try to do is balance the power between states, the big states, to prevent any one state from dominating the system. While at the same time you do try to have as much power as possible. Now, this is called the balance of power. States work to try to prevent one other state from dominating the system, which means that in one case where if one country becomes the dominant power, realists believe that all the other countries can band together, gang together to overthrow that one strong power. And so some realists explain World War II in that way, that Germany had become the main power and the other states band together to overthrow Germany. Now, polarity is one of these concepts. So polarity means that there is a main or a key power. If it is unipolar, okay, it means there's one great power. Okay, that can be a bad system, right? Bipolar means that there are two major powers. The example here could be the Cold War, where you had the two superpowers and their allies in each system. There are examples of tripolar, right? In some ways you could say that World War I and World War II showed an example of tripolar, where you have three main powers that are involved, but they usually resolve themselves to bipolar situations. Self-help has a few different ways of describing it, right? But in this case, self-help can mean unilateralism, which means one power acts on its own right to take action, to do something. So that would be a unilateral act. The opposite of that would be multilateral action, so a coalition of countries. Security dilemmas are created if a state arms to increase its security. So let's say the United States is worried about the state of its security, so it keeps building up armaments. But in so doing, it arms itself so much that it threatens other states, that Russia or Great Britain, France, China, Canada, they all say, hey, wait a minute, the United States is super armed and ready, and that's a threat to us. Because what does that mean? If you're a realist, it means it's increased its power, right? It's increased its material armaments, right? So if we go back, in relative terms, it's increased its material capabilities. And those material capabilities are a threat to me because the world is in a state of anarchy, and the world domination is a non-zero-sum game. Therefore, it behooves me to respond because it's a threat. So realists will argue that war can be waged for defense, to defend interest and the integrity of the state, or to deter action that would harm a state's security, so to prevent that, or to compel other states to stop threatening. That would be compellence. So if we were to paint a picture of the world as realists see it, this was the picture your book used, and I think it's pretty accurate. So states, you have these big circles or big spheres that represent major powers. Each state is sovereign. There's chaos or anarchy, a lack of order necessarily, or law in the international system. Some states have more power than others. And so what that also means is that states will create alliances or group themselves together as a way of securing their power. So they'll combine themselves into even larger power. And so you have this block versus this block. It looks like a big barbell. So that is how realists view international relations. Now, famous realists include Henry Kissinger. So this was a dominant view of international relations, especially in the years following the Second World War. We will see the other models. Realism is one of the more complicated ones, so you'll forgive the length of this video, but I wanted to make sure it was as clear as possible.